Good evening, everybody. Welcome to today's program, the Science and Technology Lecture Series at the IIC. Since I see a lot of new faces, let me just give you a brief background about this series. My name is Shobit Mahajan. I teach physics at the University of Delhi. I am helping IIC organize this series for the last 2 years. This series is a monthly series where we have a talk every first Friday of the month on a topic in science and technology, physics, chemistry, biology, computers, mathematics, for the lay audience. The audience is not supposed to know anything about the topic, and therefore the whole idea is to sort of popularize some obscure topics in science. This is obviously not the first Friday, but this month's first Friday was Holi, so we shifted it to today when Ratish was free today and he was not free tomorrow. Next month, first Friday, whenever that is, we have a talk by Jyotsna Seth, who's a professor in microbiology. Jyotsna Dhawan, who's a professor in microbiology at CCMB, Hyderabad. She'll be talking on stem cells. And then in May, on 1st of May, we have a talk by Mukund Thatai, who's at the Indian Institute of Science, who's going to be talking about cellular evolution or synthetic biology. Okay, so these are the two things which are lined up for the next 2 months. Today we have Ratish, and I'll leave the floor for Mr. Janhwij now, who's going to introduce the speaker. Okay, thank you.
Thank you very much. Good evening to all. I don't know, I'm sure we all know Ratish Nanda very well, so it is very little for me to kind of introduce him to you all once again.
He's not done his homework.
Yeah, surely. No, Ratish and I, we know each other for the last 20 years. We're almost same batch. But Ratish is a conservation architect. Ratish obviously started, and I know him for the last 20 years. He started searching for historic buildings in Delhi, published a wonderful 2-volume book on the Delhi's unprotected heritage, and he listed about 1,200 of those buildings. Then his stint with AKTC, where first he worked at a very sort of a challenging project of restoring Bagh-e-Babur in Kabul, where he spent I think 5 or 6 years, and then he came back and he's partnering with the Archaeological Survey of India, and I happen to be working within ASI at the moment. The partnership with AKTC began with the restoration of the Humayun's tomb gardens, and it subsequently led to a much larger project which then went on to the conservation of Humayun's tomb. And not only Humayun's tomb, but then the precinct around Humayun's tomb that includes Nizamuddin, and that includes Sundar Nursery. So there are a range of monuments within these areas, and that all came under the ambit of conservation. Now, what is very interesting, and I wouldn't be taking too much time because I would let Ratish do that talking, but what was very interesting is that the conservation here for the first time became a kind of a fillip in expanding the notion of conservation and making it much more multidisciplinary and scientific. Of course, ASI has been undertaking conservation for the past 100 or 110 years now, following its own conservation philosophy, and we've just recently updated our conservation philosophy. But working with the AKTC, with Ratish at the helm, has been a very interesting experience for us all. The kind of methodology that was evolved out of sort of a mutual consultation, the scientific approach, the exemplary documentation work, the condition appraisal that has been undertaken at all the monuments, which was being monitored at various levels, and I was fortunate to be a part of this monitoring mechanism. So this whole initiative has been very exemplary, has been talked about, has been covered extensively by media, and as a result, I think the government is very seriously talking about replicating this model elsewhere in the country to other World Heritage properties and to other prominent monuments as well. Ratish today, as my understanding goes, is going to talk about how that scientific approach or methodology towards the conservation of Humayun's tomb and other adjoining structures, how that was developed, the kind of material investigation, the kind of laboratory analysis for the tile work. He brought craftsmen from all over, from different parts of the world, from Uzbekistan, from Iran. So the whole range of investigations and analyses was undertaken, experimentation was done. One important component was the use of lime and how we go back to the traditional ways of manufacturing and using the lime. And in fact, that was very beneficial in a sense that more than 120 archaeologists and engineers from our organization also got a training, and they were sort of updated on the techniques of preparing lime and its application on the monuments. I think I wouldn't speak much because I would let Ratish do most of the topic, and I would now request Ratish to kind of give us a talk, and then later on we can have a discussion on that.
Thank you. Good evening, everybody. It's about a year or so ago, and I mean I must compliment you on your advanced planning, because about literally a year ago I was asked to do this talk, and I said 1 year ago, yes, I will do it. But it was an interesting topic of talking about the science in conservation, and I immediately agreed with when Shobit called me, and it's always a pleasure to talk at the ASI, and it's a double pleasure when Janhwij Sharma, who's the Director of Conservation at the ASI, at the Archaeological Survey of India, is chairing. So as Janhwij said, we've sort of been interacting professionally and working very closely for the last few years, but for over 20 years. I understand that the format is that I speak for about 40 minutes and then there is about 40 minutes of questions. I hope that works for everybody, but it is a small familiar audience, and if anybody has any pertinent question about any one slide, I don't mind being interrupted. Light और बंद हो सकती हैं? Bas, that's great. I'm not here to talk about the Humayun's tomb conservation per se, but I will try to limit myself to the science in the conservation effort. Now, as Janhwij did explain that the Humayun's tomb conservation being implemented by the Aga Khan Trust for Culture, and I do get a lot of credit being sort of the face, but a lot of my colleagues are sitting here, and it's a great team effort. But what I would like to sort of emphasize, and that is one thing that conservation in India is so far lacking. What I would like to emphasize is that conservation is actually a very, very multidisciplinary approach, and I'm very privileged to work together with people who are doing all sorts of different work associated with conservation. But through the lecture in the next few hours, you will understand how sort of disciplines as diverse as chemistry, physics, mechanical engineering, structural engineering, hydraulic engineering, metallurgy are all playing a part in the conservation effort. When any of us conservationists start, or at least we should be doing, one of the things that we should be doing is looking at what the building has been through since it was built, essentially to understand any interventions that might have happened and understand why any deterioration has happened. And finally, what is absolutely critical in the conservation world is to understand the significance of the site. Now, I'm not going to, as I said, I'm not going to go into the philosophy of what we do, but one of the critical things that we've brought back to India through the Humayun's tomb conservation, and the Humayun's tomb conservation is not only the Aga Khan Trust for Culture, but also we received significant funding from the Sir Dorabji Tata Trust, in addition to, of course, the Archaeological Survey of India's partnership, is going back into a craft-based approach. We all know that in India we pride ourselves on being an ancient civilization. we have been building buildings in stone for thousands of years, and definitely for at least 3,000 years before the Mughals really came in. And for 3,000, all of us live in houses. All of us use buildings such as the IIC. I should ask Premila if any repairs have already been needed for this building. But the fact is, as soon as a building is built, it starts needing repairs. And for 3,000 years, we've been conserving our monumental heritage. And we've had traditions. And Professor A.G.K. Menon, who's in the audience, was my director at Architecture School and one of my biggest influences in life. So one of the things that we're talking about is craft-based approach and using craftsmen as a center. So through this work, we've tried to bring the craftsmen back into the decision-making process. So when you look at this building, this photograph, if any photographs are out of place, my colleague Archana is sitting here, she's put them together, we can all blame her. But if you look at this photograph, what strikes you is a few things. You can see the river in the background, and you can see this dash of blue. Now this is a Victoria and Albert sketch, and when we came up to Humayun's tomb, it didn't look anything like this. This is a very important photograph because it dates from 1849. It's the earliest. Photography was really invented in 1842. So having a photograph discovered quite by chance in the Canadian Centre for Architecture in Montreal, what is important about this photograph is this channel that you see and this water tank. Now this is important because the British altered this whole landscape in the mid-19th century after the First War of Independence. And then Lord Curzon actually, once the Mughal Empire declined, so the way these buildings were preserved were basically, the king and the empire would give annual grants, the king would come, Shah Jahan, Akbar all came, would give grants, and the craftsmen would keep it in good nick. But once the empire declined, this is what happened to Humayun's tomb. And then 1857 saw a lot of damage happening here. So that 1849 picture is important because of what Lord Curzon did here. Now this is Lord Curzon, and so far it's been believed that the landscape has been huge interventions by him. But there is evidence. So what Lord Curzon did was gave strict orders to restore the garden to what it was before the First War of Independence. And we know that because in the southern section of Humayun's tomb, there were some channels added, and because the archaeologist was asked to restore the channels, and the conservation assistant on the site actually sent a message to the Director General saying, we have not found any evidence of channels in this section. And the note went all the way up to the Viceroy, who said, put them in the center of the channel anyway. So these are important things to know. And then, of course, 1947, independence, horrible thing like partition, refugees, all the wood at Humayun's tomb was burnt and used for firewood. So a lot of damage happened. This is the condition we inherited the garden. Now this is absolutely critical because there is this whole science of hydraulic engineering, and the Mughals took it to a very fine art. The Humayun's tomb is the first garden built on the plains. Before that, this whole Iranian tradition of building charbags came from Iran, Afghanistan, Uzbekistan, and it was always along flowing water. The Humayun's tomb was also sited along flowing water. And today, this morning, I had a very interesting interaction with Professor Sunil Kumar of Delhi University, who actually has a very strong thesis that all these cities were built near flowing water. But this was where we started. His Highness the Aga Khan gave a gift to India on the occasion of the 50th anniversary of India's independence to restore the gardens. And one of the critical things in restoring the garden was restoring flowing water. Now, how does flowing water flow on a level land? And this is where all sorts of technology was required to revive this flowing water. But essentially, what is happening now is that the water is put in from one side and it slopes down these channels on a slope of 1:4,000, which means a 1 centimeter drop for 41 meters. We could do it because we had the most sophisticated surveying equipments, and we had a whole team of engineers supervising to the extent that every 5 centimeters a level difference of 1 micron or God knows what was taken. These fountains today run on the basis of mechanical pumps. But historically, these fountains were fed with terracotta pipes. Water was lifted from the well, taken to the height of the walls, and terracotta pipes took, so it would have been a little gurgle, but the excavations carried out by the Archaeological Survey of India as part of the project proved that hydraulic engineering in the 16th century had so advanced that you could run a fountain on a plain ground, and which is very interesting for me. So this is with the finish. The garden restoration led to a 1,000% increase in visitor numbers, quite apart. So at some point we left the site. As Janhwij said, I spent a few years in Kabul restoring Bagh-e-Babur. And then we came back to a much more daunting challenge of working on Humayun's tomb, and which is part of a much larger project with social economic development and so on. But let's today talk about Humayun's tomb. It's a World Heritage Site. There are various norms, and unfortunately, there is not enough research on really material research. So this topic of this talk today, science and conservation, is unique for India. I mean, it's not being talked about, and I'm also struggling here. But Edinburgh and Scotland happily has the same stone, and millions and millions and millions of pounds have been spent over the years studying the effect of deterioration on sandstone. So we had access to a lot of that science, but before anything could be done, we needed a stone by stone assessment of every damn stone in Humayun's tomb. Before we could take a decision together with the core committee of the Archaeological Survey of India, which stone is to be replaced and why not. A lot of this deterioration really happened on the lower plinth, and this happened because of two reasons. One is the water was percolating, and the second is the joints of the stone had been filled up with cement. Now this is very basic common sense more than science, that is one of the principles of conservation, is that whatever new material is added should be weaker, lighter, and sacrificial. So what happens is when the joints of the stone are filled up with cement, the cement is harder than stone. So whatever water is coming down and bringing whatever salts with it, it sets off a deterioration process that cannot be reversed, because the water is then coming out of the sandstone, which is porous and so on. It's a sedimentary rock, followed by a whole analysis of the structure. So this is in a nutshell what Humayun's tomb looks like, and this is the structural thing. So the main core of the base is masonry. It's like building a mountain. But talking about just for a minute about geology, what did happen is we, as part of the garden restoration, did a whole series of tests, including ground penetrating radar survey and so on. To our shock and amazement, what we found was that Humayun's tomb really stood on a rocky outcrop. That this was not, even though this was on the river bank, there was a hill on which Humayun's tomb was built, and that provides added security against earthquakes. And it was, I mean, Delhi is not really rocky except for the ridge, and over here you assume that, but the surveys were very clear that there is a rocky, and Nila Gumbad also sits right next to Humayun's tomb on an island that was in the river. So the center of the tomb, I can't see the slide on my screen very well, but is mostly masonry, and then there is this whole underground vaults which have over 160 graves. There's a huge double dome, absolutely large, and for that, I mean, Humayun's tomb has absolutely no precedent anywhere in the Islamic world. One of my colleagues, Mona, who's sitting here, is from Iran, and I've gone through Iran and Turkey and Uzbekistan looking for buildings that would have inspired Humayun's tomb. There is none. Throughout the Islamic world, all of us talk about the Persian influence and this influence and that influence. Yes, there is Persian influence in parts. The architect came from Herat in Persia. But there is no building quite like Humayun's tomb anywhere in the world. And sorry, sir, we didn't know you were coming, otherwise I would have held off. But the double dome is massive, and we had to go through a whole structural analysis of how the load transfers from the dome down to the foundation. And yet, huge surfaces. These are huge surfaces for a building. The building covers an area of 2 acres. Now, how many buildings do we know which cover a floor plan of 2 acres? As a result, today, when a building this large is built, engineers introduce what is called an expansion joint. What is an expansion joint? Literally, there is a gap between 2 columns and so on, so that when the building expands, but Humayun's tomb does not have an expansion joint. As a result of which, there are various cracks. That is one of our structural engineer Stuart Tappan's drawings, and that is the line of cracks that you see at Humayun's tomb through the plinth. What do we learn from this? We learn that these cracks have been caused by thermal expansion, and it would be best for the building not to fill up these cracks, not to repair these cracks. Now, as a conservation architect, my first instinct is a crack, let's stitch it up. And our structural engineer is saying, let it be, because if you fill it up, there will be other problems. So, this whole transfer of load, I mean, how did the Mughals in the 16th century get it so damn right? In more ways than one. I mean, you know, I personally believe that the whole concept of architecture and engineering did not exist in India till the Europeans came along. So there were no drawings made of these buildings. They were master builders, sthapatis for temples or whatever. Well, how did they get it so right to be able to build a building absolutely accurately? There's not much conservation in India that happens outside the government, outside the Archaeological Survey of India. And I say this with a bit of shame rather than sadness than pride, we remain today, 20 years after we started with the Archaeological Survey of India, as the only private organization partnering with the Archaeological Survey of India. But one of the things is when you're sort of a private agency, you're more concerned about what is peer review, what is the international expert community going to say, and so on. So in many ways, we have to cover our bases. And one of the biggest criticism of work in conservation in India has been the lack of documentation. So a lot of criticism, oh, you've not done your documentation, and which is quite accurate, because we might be making mistakes. And how will the world or the future know that we made these mistakes? The only way someone 50 years from now is going to say, okay, these guys messed up, is if we document what we are doing, what is the state of the building before. So we introduced this technology in India called laser scanning. Now, this is a machine that was invented to detect leaks in nuclear plants. And so it's very accurate. So it's basically meant to detect any cracks, anything in a nuclear plant. And so the laser scanning, we were able to get this machine and do a lot of training both within the ASI and outside to how to use this. Now, this has become, since this was used here 7 years ago, this has become quite standard practice for conservation worldwide. What this machine does is able to, just like a scanner, it doesn't go through a building, but just like a paper scanner, scan the whole surface of a building. And even if a building like Humayun's tomb doesn't need, sculpture and all that, you can't make a drawing easily. We can make a drawing, but the intention behind scanning the building was to leave an absolutely accurate record of the state of the building before we started any intervention. And they've just recently, I think about a couple of months ago, scanned the pyramids and realized that all the previous drawings of the pyramids are totally wrong. The crypt is shown in the wrong place, everything. So this is a technology that is today, and this is the dome, this is the scan of the dome, and it shows it's not really a straightforward dome, but it has its undulation. So every square micron of the building has been scanned like this. Finally, who does Humayun's tomb belong to? As a World Heritage Site, it belongs to mankind as a whole. And when I say mankind, I also mean womankind. But it belongs to mankind as a whole. And as a result of which, it's absolutely critical for us to, engage in independent peer reviews to understand what we're doing. And this was one of our most exciting peer reviews. You see Professor Menon sitting on one side and Herb Stovall, who's sadly no more, sitting on opposite him. But essentially, in terms of just scientific approach to conservation, the Archaeological Survey of India Core Committee reviews works that we do on a monthly basis. It's supposed to do on a monthly basis. Sometimes it's 3 months, but every work, every brick is reviewed. And then we do 6 monthly international peer reviews. If my memory serves me right, Professor Menon was in this peer review on behalf of the Sir Dorabji Tata Trust, and World Monument Fund was involved because this was some funding. This was a very interesting peer review, and I'll come back to it later. But I was just mentioning this in terms of the scientific approach to conservation. Now, all of us know that all of us know about dead load and live load. I mean, this building has live load because there are about 50 of us sitting here, and then there is dead load because of the walls and so on. Now, through the 20th century, because craftsmen had been replaced by engineers, literally 1 million kilos of concrete was added to the roof of Humayun's tomb. So that is the level at which, and this is a problem that buildings have faced all over the world. I'm sure there is 1 million kilos of concrete on the Taj Mahal's roof, or maybe half. But through the 20th century, modern materials such as cement were introduced, and they are today one of the main reasons why we have to do conservation work. It's not only neglect, but it's also inappropriate conservation. Now, it says something about the structural stability of this building, which is meant to take a lot of abuse, that 1 million kilos of concrete did not really have much impact on the structural stability of the building. It had all sorts of other problems. It blocked the rainwater spouts, the roof became like a swimming pool, the water percolated, rusted the iron clamps, all of that. But we needed to remove that. So that was, again, removal of that concrete was a very challenging scientific exercise. The reason for it was, how do you remove 1 million kilos of concrete? What is the first thing that anybody can think of? Is mechanical cutters and just cut the damn thing out. But remember, you're on the roof of a building that's 42 meters high. What will the vibrations from a mechanical cutter do to a building? So we had to actually, the process for that was, we had to get a diamond blade and make 1 meter grid cuts 10 centimeters deep, and then import a tool which had absolutely minimal vibrations and make that diamond cut slightly wider, 5 centimeters, and then it was all manual chisels. So our craftsmen had to remove, who are used to making stone for construction, removed 1 million kilos of concrete from the roof without causing any vibrations and further structural damage. While we're still on cement, that is what had happened to bits of Humayun's tomb. And I'm not saying that this is Humayun's tomb only. Let me emphasize again and again, throughout the 20th century, cement was a favored material of those responsible for archaeological buildings, architectural monuments all over the world. Whether it's Italy, France, UK, everywhere, cement was being chosen material. It was this new modern miracle. It was the Viagra for conservation. But anyway, so a lot of the monuments were suffering with cement. Now, I want you to, for a moment, forget the cement. Just not look at the cement, but look at what's happening around it. Look at the stone and the deterioration the stone is suffering. Now, this is because cement is so hard that the water is actually coming, and this is structural stone. This is a true arch. This is not cladding. This cannot be touched unless I bring down the whole building. So the cement is not to be removed because it's ugly. It's not an aesthetic argument as some of our critics have made it out to be. It is a need for the preservation of the monument because the stone is just deteriorating. Why do monuments survive? What was the historic traditional building material? Now, traditionally, we were building either with mud or with lime mortar. I'm talking about binding bricks, binding stone. So why does lime work? Because you take CaCO3, which is limestone, and you burn it in a kiln. Limestone, the chemical properties of limestone, CaCO3. You burn it in a kiln, bhatti mein, and what happens is that the carbon dioxide is let out. Now this is a very important, we've got this up at Humayun's tomb, and this is very important for conservation. And once the carbon dioxide is left, you're left with calcium oxide. You take that calcium oxide and you put it in water, and it's a exothermic reaction, so you can see the heat that is coming out, and the water is absorbed and it becomes calcium hydroxide, CaOH2. And then you take this literal, what the water does besides changing the chemical properties, it breaks down the lime particles into small microns. Those microns are then taken, and I don't know whether that image is clear, and I'll show you a better one in a minute. In a aate ki chakki, we've all seen a grinding stone. That is taken, lime is put, and it's mixed with sand. 1 lime, 3 sand, and mixed so that each and every particle, micron of lime is covered equally with sand. And then it is used on a building. So you use it as plaster, as mortar. What happens? The carbon dioxide is absorbed and the water is given out, and it goes back into its natural state of CaCO3. Which is why historic buildings survive, because you're literally building out of limestone and it's going back into limestone. With a little bit of maintenance, these buildings will survive forever. So just to recap what I just told you, that is a kiln, a bhatti, which is burning the lime. So the lime and all the impurities are burnt. You get something like this, which is lump lime, very light. This is put in water and soaked in water for up to 3 to 4 weeks. We keep it at least for 3 weeks. Each particle breaks down. It is sieved, and all bigger particles are taken out and thrown away. And then you got various additives. So what this guy is doing is putting molasses in it. And there are other additives like fruit pulp, brick dust. Brick dust is pozzolanic. So what it does, it creates cavities inside the mortar and brings in the air so that it can set quickly. And then the millstone, it goes around and around, and it just, and then finally it's used. So what was, this is the picture I started in. When we removed, we found some of the historic patterns. We were able to, this is the base layer. So the lime is applied in several layers. This is quite thick, 3 to 4 inches. And we put in the patterns. We had to train craftsmen for this. We needed 3D laser mapping, 3D printing to make sure that these patterns were equally right. Now, all that science of geometry and all that I'm unfortunately not able to explain, but all of these patterns were restored, and then the lime and the red was going back. Now, this is something that people got a bit annoyed about, because the building is not looking like a ruin anymore. Now, all of us have been so influenced by Europe that we like this ruins in the English landscape, and we were quite aware. We were quite aware that this is going to be criticized. We were quite happy to leave this building like this. But then we did this horrible thing called the peer review. And sitting in the south gate, I still remember that scene very clearly, sitting in the south gate at about this distance from where this photograph has been taken, Professor Menon turned around and saying, "You can't." "Why can't you, sir?" "Because it's the red and white. The Mughals wanted a red and white thing. And from here, it looks like a whole sense." And thank you, sir, for insisting that we put the white back, because it on hindsight, even though it was quite a tough negotiation, it was the right decision. And so when I said we have to go back to what the Mughals wanted it to be, so this is the red and white contrast. And the white in the lime is actually meant to mimic marble. So they're using a cheaper material, but it's meant to mimic marble. And they're using it only where the building is protected, and the marble does not need to be there as a protective layer. So these are things that you learn as you go. The canopies. This is the next section, and I'm keeping a close watch on my time. I see I've spoken for 21 minutes. The canopies. Now, where did the Mughals come from? Where were the builders? As I said, the Humayun's tomb is one of the finest examples of Mughal architecture. It is what, as Ebba Cox says, set the tone for imperial Mughal projects. This is where imperial projects were really set, and this became where the whole Mughal funerary architecture started. But where did the Mughals come? What was home? The home was Timur. Timurid. Unfortunately, they're called Mughal. They should be called the Timurids. That's another story altogether. Babur would turn in his grave if he knew his dynasty was called the Mughals, because he hated the Mongols. But Timurid, Central Asia, Iran, Uzbekistan, that whole area. And so this is the blue. Now this blue is a little reminder of home. It's not protective, but it's a very, very important architectural element. You'll see in this 19th century sketch that it's very visible. It's only a dash of blue, but it's very visible, it's very prominent. And it was an important intention of the original builders. And that's what conservationists such as myself try to seek. What was the builder trying to do here? This is what we inherited. And like in many cases countrywide, we realized that it might be too late to really think of putting tiles back because the patterns are not visible and we cannot do any conjecture. So we will not put anything back on the tomb which we did not know for sure how it looked like, because that would be adding your own opinion or aesthetic opinion on it, and we would not do that. So everything that we do is based on evidence, one way or the other, archival, material, on-site evidence. But happily, once we started scraping off the cement, we started figuring out the tile patterns. This was brilliant. This was the eureka moment. This was at least my eureka moment. I was not in a bathtub, but you know, a lot of the tiles had survived, and a lot of them were missing, like this whole patch. But what survived gave us enough evidence of what it originally looked like. So we did these models of what it looked like. Then was the next big scientific challenge. This craft had died out in India. Unlike the stone carving, unlike all of that, this craft had died out in India. So what do you do? If today, if we knew then what all we will need to do, we would probably never embarked on this journey. The total square footage of tile work that we wanted to put back was less than 12 square meters. And it took us 3 years, more than a crore of rupees to do the scientific research to be able to do this. So we started with chemical and physical analysis of what existed, the tiles that existed, to get the colors right. I don't even know what all these things are, but electron microscopes and every scientific total, and this to XRD graph to work out what are the chemical compositions of the glaze, for example. Now, it's all right to say this is turquoise, but turquoise doesn't mean that actual turquoise is used. Turquoise simply means it's a color, and it comes through a whole process of glazing. And a lot of people think this is what, it's turquoise, so they must have taken a lot of turquoise stones and crushed them, and no such luck, unfortunately. So we had to figure out which chemicals were used in which quantity to make the glaze. And literally, less than 1/100th of a gram difference in the chemical would produce a different color of the glaze. It was that insane. And it took us 3 years, literally 20,000 tests, before we could even think of putting the tiles back. Since then, since we started putting the tiles back, the technology and the research has evolved many, many times over. That to the extent that we've now sort of so these are the original tiles, and these are all the various tests that, or some of the tests that every tile was tiled, date, number of hours it was kept in the kiln, composition of the glaze, everything. So this whole process, I mean, we've got a film here, and my colleague was saying we should show the film here today, but we'll leave that for another day. And then we had to get Uzbek craftsmen, as Janhwij said, that guy on the left is Uzbek, to help us work these things out. Even they could not work out the turquoise color. It took us 2 years to work out the turquoise after they'd left. So somehow this turquoise is not available in Iran, it's not available in Persia, in Uzbekistan. It's very unique to Delhi. And this is not the general thinking, because there is so much turquoise in Iran and all that people think it's coming from there. It's not. It's a variation in the shade, and we were able to employ local youth from Nizamuddin for about a couple of years to do this work, and make kilns and really very, very scientific interactions on these, and we've got about 17 different shades of color that we can use. And finally, the pattern. So you can see that the original tiles existed. Sorry, I'm trying to find the ayah. So you can see the petal, and this is only possible. The only place you can see these patterns is from heaven, because you can't see them from the ground. But we had to get it right, and so these patterns worked out, and this is all patches of cement, which were then removed and the tiles put back, and this is what it now looks like today. And this is an image of the building with the tile. Unfortunately, there was a lot more tile in the building. The central chamber was tiled. These tiles were removed sometime in the 1950s, and we can't put them back because we have no evidence on that. All of you will remember, and this is probably something that will interest you, all of you will remember that I spoke about the laser scanning, and some of you will know that in the storm of May 30th last year, the finial at Humayun's tomb was knocked out. And that set the Archaeological Survey of India and us on a long path of trying to understand the finial. And we because of these laser scans, we were able to actually get the real dimension, because the fall led to the finial really compressing in all sorts of manner and all sorts of shape and disfiguring this whole thing. This is a slide from 2009 when we were working on the dome, and we did study the finial, and we did discuss, Janhwij and I both had this long discussion about what to do with the finial and whether we should take it out and inspect it. But this is 18.5 feet. It's a 2-storied building on top of the dome, and you don't really want to take down a 2-storied building unless there is enough reason to do. And I remember Janhwij standing on top of there and sort of saying, this is quite solid, let's not touch it. And we left it at that. And then, unfortunately, the filion collapsed. It collapsed because of, again, past inappropriate conservation. This was replaced once the British had actually taken it down in 1911 in the hope of putting a lightning conductor through it. That failed, so they put it back. But in the 20th century, cement repairs over there had led to the water passage being blocked. We had to put the lightning conductor, so within 1 day of it collapsing, we had the scaffolding up all the way to top to put the lightning conductor. But this is the finial. And it had never been inspected in this state before. None of us, including the ASI, had been able to look at this finial in such close detail. And what was revealed was amazing. What was revealed is, in the 16th century, metallurgy had advanced to such state that they could make a 2-storied building out of copper. And the joints with sort of teeth joint are so perfect, and they're taken 8-inch strips. But more than anything, it's for the art historians that this was amazing. So that we found a lot of inscriptions. We found artwork. We found a kneeling man praying engraved into the finial. So it was the Archaeological Survey, the Director General of the Archaeological Survey of India decided that this would be best preserved in a museum environment, and we would put a replacement finial up there. Now, even now, we are not able to get copper sheets of the purity used in the past. So this is 99.6% pure copper in the 16th century. And more than copper, it's covered with gold. So we estimate there's about 10 kilos of gold on this finial. And it's embedded into the copper, so the gold can't be stolen. It's just, and for the life of me, 16th century. We're talking about 16th century metallurgical advances. And now we've worked with traditional craftsmen to try to figure out, this is actually gold plating in progress and how it could be done and so on. But essentially, we've now been able to, the crown and so on. These are things that have never been inspected at such close distances. So this alternate finial is going to go up sometime soon. And the other one is going to be repaired and put into a museum. Gosh, I need some water. So that was the finial. So I've spoken about chemistry. I've spoken about physics. I've spoken about metallurgy. I've spoken about the science of historical sciences. I've spoken about geology, and finally geometry. I mean, how did somebody in the 16th century work out these patterns to such a fantastic scale? And this is all pure geometry. It's amazing that some of these patterns, and their whole PhD is written on this, of how did a craftsman. Today it's very simple. We take a computer, scan the pattern, take a printout, and print it out on an aluminium sheet. There are holes in that. We put in a die, and the craftsmen follow that pattern and carve out the jali using hand tools. But there are hundreds of patterns of jalis at Humayun's tomb, literally. And each one is unique, each one is geometric, each one is totally symmetrical. I think somebody needs to do a PhD on geometry of some of this stuff. Owing to the dargah of Hazrat Nizamuddin Auliya, one of the most revered Sufi saints in India, the site we work in is actually is really part of a dense ensemble of medieval Islamic buildings. I used to say the densest ensemble, and my colleagues used to laugh at me, but now I work in Hyderabad, where it's even denser, so we just say one of the dense ensemble of medieval Islamic buildings. The profusion of tomb building. So we, at the moment, together with the Archaeological Survey of India, are working on about 50 monuments in the complex, all of which are being dealt with the same level of scrutiny, same level of work that the World Heritage Site of Humayun's tomb is benefiting from. I would like to take us away from the main topic of the lecture, which is Humayun's tomb, and just for a minute talk about another building, if I may. May I? Thank you. So this is the Chaussat Khamba. It's a unique building, and I have lots of theories about the Chaussat Khamba, which I love talking about. But Chaussat Khamba literally means 64 columns, and there are 64 columns on this building. This was built as a tomb for a family called the Kokaltash, who actually had their own palace where Sundarnagar now stands. This palace was demolished to make Sundarnagar. And the Kokaltash family built this unique marble, and I don't use the word unique lightly. I'm not calling everything unique for the sake of it. There is no other building anywhere in the world like this, built 100% out of marble. It's clearly inspired by the Iranian garden pavilions, such as the Chil Satoon and so on, and then in turn inspired the Diwan-e-Khas and the Diwan-e-Arms of Shah Jahan. So this is a very influential building, but quite apart from architectural styles, it is a wonderful building. It's built of marble, and but the problem is, how is the marble fixed to one another? Very basic science. You take these big blocks of marble, carve them in the horizontal, carve them in a vertical, so each piece of marble is unique, and then you put an iron dowel on top and fix two adjacent pieces of stone to one another. Now, all of us know what happens to iron when it meets water. It rusts. And believe me, when iron rusts, it expands. And when iron expands, it elbows out the marble. So the drawing up there, done by one of my colleagues, a conservation architect called Nitipal Brar, actually that marks the damage to the building. And what would anybody do? What would anybody do? You would just fill that up with cement, and that's what happened. Unfortunately, that only accelerated the decay. So when we inherited this building, it was on the verge of, and I don't say this lightly because a lot of these buildings were built to take a lot of abuse, but this was on the verge of collapse. And so we had to, this is the plan. So you have these 25 domes and 4 columns in the corner and 2 columns in the outer facade and 64 columns. So this is a laser scan of the roof. And these are the cavities. After you take out the cement, you can see how big the cavities were. These were the cavities, and obviously the stone was not going to survive too long. So we had to actually take down this building. And it's never been done anywhere in the world before. And the only reason we can do this, not because we are the Aga Khan Trust, but the only reason we can do this is because Indian craftsmen are still capable of creating magic. 200,000 man-days of work by master craftsmen was used at Humayun's tomb conservation. 200,000. Anywhere else in the civilized world, people will be saying conservation generates employment. But we don't care. 200,000 man-days is nothing for us. But our craftsmen, after about a year of working on one dome, figured out how to fix this. And under constant supervision of a full-time conservation architect, full-time engineer, this project took us almost 4.5 years, where this whole building was dismantled, every piece of stone repaired, and put back in its original place. The only thing that was not put back was the iron dowels. So we had to take out the iron dowel. This is the amount of cracks, this is the iron dowel. We had to take out the iron dowels because they're rusted and replace them with, and this is each building numbered. This is the dismantling process. And, each ring put up, and then the cracks filled in, and these are all the cracks filled in. The keystone is kept in position, and then each stone block going back where it belonged, but only this time with stainless steel dowels. And this itself, I mean, I don't want to talk to this audience, tell them how rust happens, but essentially this was one of the most challenging conservation effort that we had to undertake. Last few slides. That is a machine very little used in the conservation effort. That is ground penetrating radar survey. Now what it does is it scans the earth and it reflects back depending on what it hits. So if it's stone, it's metal pipes, you get different images, and people, without investigating, without archaeology, you can tell whether there is an existing building such as this. In this case, it shows you a column structure, so you don't know. And then you can dig at a specific space to find out whether the column structure dates from the 19th century, 18th century, or even the 21st century. That it won't tell you. It will simply tell you what is the material below. Metal, stone, brick, all have different resistivity. So we did a lot of this. And we did a lot of this for various reasons. But most specifically, and these images are not related to that, we want to build a site museum. And 2 million people now visit Humayun's tomb, and we want to build a site museum so that the site museum is not interrupting the visual linkages between monuments. It's underground. So before we even started planning, about 4 years ago, we did a whole ground penetrating radar survey of this, and accordingly did a lot of trial tension to find if there was any possible archaeology on the site that needed to be documented or salvaged. This was done together with the use of archival material and so on, and we were sadly no archaeology really came up because there was a road here before and they had construction here, so a lot of it probably, if there was anything ever there, it had been destroyed. I think that is the end of Humayun's tomb. I can just stop there. So, thank you very much.
Well, thank you very much, Ratish, for this fascinating presentation and rather a journey that you took us all through. And in fact, I've been a part of this on many occasions. I would quickly browse through some of the important points that he raised during his presentation, and then we'll open the floor for discussion. Very interesting that you mentioned, and I totally agree with that. Conservation is a multidisciplinary approach. It's no longer prerogative of an archaeologist or an engineer or an architect, but there are many more professional disciplines who can actually inform the conservation process and the conservation decision. Again, important that you highlighted the aspect which is adopting the craft-based approach. In fact, in our modified or new conservation policy, this is one of the prominent aspects that we have looked into.
You recorded, huh?
I know that. I know that. And
no, it's important for the archaeological survey of India to say that this is how we're going to go ahead. So.
And again, when you started with your presentation, the series of archival images that you showed us indicating how the Humayun's tomb fabric changed and evolved or deteriorated, whatever, over a period of time, and how it informed your conservation decision. You told us about hydrology and how Mughals treated it as an art, which is something very interesting. Use of cement, which is something which is talked about in different fora, and obviously mostly as a kind of a thing which has happened, but it shouldn't have happened. But we all know that that was the material or the understanding at that point in time, so that is why it was used. But now we have started obviously understanding that how cement has actually contributed to the deterioration. So even in the ASI also, we're in a process of removing it wherever it has been applied. The application of GPR surveys, the laser scannings that you've done, and how it has contributed to the documentation and informing conservation, taking conservation decision is another aspect that you highlighted. You raised a point, and I think it is quite interesting that there are not many private initiatives in the field of conservation, and that they are partnering with ASI. You're of course the most prominent example to us, and there are one or two more agencies, but it's something that we all need to look into. Documentation that you highlighted, how it is such a critical tool to understand the building, all the interventions that have been made to it over a period of time, and how that leads us to not only archiving, but it also kind of informs us that what kind of conservation decisions or interventions that need to be taken. You mentioned about the monitoring and how that is a very important aspect of the conservation process or the decision making, and how again it is a very multidisciplinary enterprise. It's not that it's only the ASI and AKTC were sitting together to take these decisions, but there were a whole range of other stakeholders and participants as well. Your story of removing 1 million kilograms of concrete from the roof of the Humayun's tomb was another very interesting aspect. When you talked about the lime cycle, what actually fascinated me in that image was actually that when the grinding is taking place, you are again using the traditional way of doing the traditional way of kind of grinding, and not using the mechanical means, and that's something very interesting.
If it's worked for 1,000 years.
Yes, and it can work even now as well. Yes, and another important aspect you mentioned, that all the conservation works that have been taken here are on the basis of evidences or on the basis of archival records, and that there is no conjecture involved. So you set a benchmark in that as well. The story of tiles craft was another very interesting example to all of us. So finally, how you kind of took us through history, to chemistry, to physics, to engineering, to metallurgy, to geometry, and how it all embroiled in the process of conservation was something very, very interesting in your presentation. I think I would stop here. We have about half an hour, and I would now open the floor for discussion and questions if there are any, and Ratish would obviously would be answering most of these. May I start with you, please?
Please wait for the microphone, because the whole thing is being recorded. Okay?
Hello. So how will you make the underground museums without causing vibrations?
Why would there be vibrations?
I mean, you stopped the building of roads near the Humayun's tomb, so wouldn't it cause vibrations?
No, the road construction, what we did stop is a whole tunneling thing, and the reason it was stopped was not only vibration. The reason the road was stopped, this is during the Commonwealth Games. There was this big road proposed to be connecting the Commonwealth Games village to Lodi Road. The reason that road was stopped was because it would get 12,000 cars every hour into subs-verge into Lodi Road, making Humayun's tomb inaccessible. It would have required 3,000 trees to be cut, 5 monuments to be demolished, and it would have destroyed the zoo because it was all underground, and finally it would cause a lot of pollution. Now, as far as the building of the museum goes, it's going to be basically excavation of earth, which nothing. There's no drilling that is going to happen. So there's no drilling. There's no vibration.
Okay. One other question. How did the Mughals make the 1:4,000 centimeter slope in the water channels?
How did the Mughals make the finial? How did the Mughals? We have a lot of unanswered questions. I mean, we were quite shocked, and even our surveyor basically said, "Forget it. This is not going to get done." That slope was just, and it was important to stick to that slope, not because of anything else, but it was important to stick to that slope because we had several water channels that we had the original Mughal bedding. So if we had gone if the slope had become any more steeper, we would have had to destroy Mughal channel, which we couldn't do. Only God knows how they made 1:4,000 channels, because there are 7 layers of plaster on it. There's a masonry bed on which there is plaster. I can't answer that for you, but if 3 attempts in the 20th century failed, there was Lord Curzon attempted, he failed. In 1924 there was another attempt, in 1942 there was a 3rd attempt, and finally in 1984 there was another attempt. All of them failed, and we were able to do that only because of the advance in surveying technology.
And how did they bring the water from the wells into the terracotta pipes?
It was lifted manually with buckets, and there was also Persian wheels. But there was a combination of both. There are 5 wells which we've discovered. At least 2 of them could have had Persian wheels, but for 3 of them there was no evidence of any Persian wheel being used, and they were probably lifting it manually.
These were on the side of the Jamuna?
They were on all sides, all 3 sides of the tomb. Not on the Jamuna side. On the Jamuna side, the water was being lifted from the Jamuna.
Any
That
other?
would make sense.
Do
The wells still existed?
Yeah,
Yes.
we've actually discovered the wells which had during the British times been filled up, and we found a photograph of the plan from 1880, and we've discovered well, and one of the wells we discovered was not meant to lift out water but actually to put back water, excess water. So it was one of the earliest known rainwater harvesting things that we come across.
And you still use some water?
We use it every day.
Sir,
Sir.
I've been involved in, this is to do more with conservation architecture than Humayun's tomb, with restoring British period buildings in Dehradun. Not that I'm an architect, but I was chairman of a committee, and we had some conservation articles here. And there too we had to use very much the same techniques as you've shown over here, including the lime plaster. We couldn't get bullocks, so we used an auto rickshaw to take the stone around. But would you say that the same principles as apply to Humayun's tomb would also apply to British period buildings, because they too are built with lime plaster?
Would you? I'll add to it.
I think, a lot of people say, "Are you an expert in Mughal buildings?" And I say, "No, I'm not an expert. Our training as conservation architects helps us to understand building, whether they're Islamic or Christian or colonial or Mughal. It doesn't really matter. But yes, the same technology, the same principles, the same philosophies, the same process."
Just like to add that in the Rashtrapati Bhavan, the same thing is being done.
Yeah.
The 1920s building. No, just to add that in Rashtrapati Bhavan, the same process is being applied for 1920s buildings.
You wanted to ask something? आप आगे ही आ जाइए.
This conservation which you have done, it needs interventions every 2 years, or it is complete in itself? And Delhi is under seismic zone, so this seismic protection is also taken care of by the architect themselves and the conservationists also. Could you highlight something? Seismic protections.
Well, I did explain that the Humayun's tomb is very cleverly built on a rocky outcrop, and it has survived earthquakes for the 4 centuries. So we have not really done anything. We've carried out no intervention that would make it more secure in terms of a high earthquake. We've done absolutely nothing because any intervention for that would be very, very intrusive in the historic fabric. As per the conservation is concerned, it's in terms of life of the conservation, such a project on one building is probably not taken place in at least 100 years, and with a little bit of maintenance would not be required to be taken for another several hundred years. Having said that, there are certain design flaws in the building. I don't know whether they are a result of 20th century alterations or they were original. For example, on the upper platform there is a drain, and that drain is inadequate in terms of high rain. So when it's very heavy rain, that drain overfills and spills over, and the water falls on the facade. And the alcoves which I showed, lime plaster, get a lot of that water, and that sets off a deterioration process. So we've been grouting those, and for 100 years, because of the cement and so on, a lot of the water has permeated. The walls are 30 feet thick. So to just dry the walls out has taken us, will take a long time, several years. In the meanwhile, that dampness. So a lot of the plaster work we're doing all over again right now in the lower alcoves, but otherwise a lot of the conservation effort will not be required to do for the next several hundred years with a little bit of maintenance.
Yes, please.
Yeah, I was curious to know if your conservation efforts have been restricted to the building structure and the water channels, or you have also been working on the landscaping, planting as part of the original setting of the building?
Well, actually, I just focused on the building, but we first got involved with the site in 1997 when the Archaeological Survey of India requested the garden restoration. The site, the Humayun's tomb, was put on the World Heritage List in 1993, and one of the recommendations of the expert international group was that the landscape needs to be restored. The Archaeological Survey of India took that recommendation very seriously and approached the Aga Khan Trust for Culture in 1997 to undertake the garden restoration. So Professor Muhammad Shahir, who was earlier at the School of Planning and Architecture, has been the landscape architect to the project, and together with the water channel, the conservation of water channel was the last bit in restoring the garden. We had to remove about 4,000 truckloads of earth to restore the relationship. We had to hand chisel 2 kilometers of sandstone, put back the fountains, restore 250,000 square feet of pathways, put in 4,000 trees. All of that as part of the landscape restoration that predated the conservation effort.
Yes, please.
So I have two questions. One is regarding the inputs that you might have got from other places. For example, the colored tiles of Registan, etc. Do you learn from that, or do the Uzbeks do research work which can be on a collaborative basis going into the future? The other thing is, and did you use any of that? The second question is, given the last few hundreds of years, the levels of pollution wouldn't have been, air pollution wouldn't have been quite the same as they are now, and what actions could be taken to protect against those?
To answer your first question, we've been seeking scientific research. As I mentioned, there's been a lot of research in Scotland on sandstone, because somehow Scotland uses the same sandstone, and so we used all of that, and that helped us decide which stone was going to be totally replaced and which stone was only going to be repaired, all of that. In addition to that knowledge, our craftsmen were involved in the decision-making process, and often our master craftsmen would say, please replace this also, because this will not survive for more than 10 years. And so when we first presented to the Archaeological Survey of India that 7.8% or something of the stone on the lower facade was going to be replaced, in the end, we replaced about almost 10% because once we started the work, we realized that a lot of other stone. So a lot of that research. In terms of Uzbekistan, it was we used traditional craft knowledge. So the team that came from Uzbekistan included a scientist and 3 craftsmen, and we learned a lot from them. But unfortunately, what we learned from them was really what Uzbekistan was using. For example, they would use a certain few herbs to create a certain thing, and we don't have those herbs. So we had to investigate what those herbs were really doing in the scientific process, and then use similar material. So they showed us the path, which we then had to go on.
Pollution level.
Pollution levels. Happily, Humayun's tomb sits in the middle of a 800-acre green space, starting from Purana Kila onwards. So there is not much impact of pollution in terms of deterioration at Humayun's tomb. But I say that only on the basis of physical, visual inspection. There has been a 3-year European Union study on the effect of the pollution on Humayun's tomb. Unfortunately, we've not been able to lay our hands on this study. It was done over a 3-year period, but we've not got that in our hand. Sorry, sir. Yes.
Thank you, Ratish, for a wonderful lecture, and also compliments for the work you have been doing there. I've seen it several times. But I have a very, very fundamental, basic question. I'm not an expert in the field. I just want to know, a monument like this has survived some 500 years, and this 500 years of its life, it would have gone through several interventions. But how do you decide whether a particular intervention was history or whether it was an intrusion by which has to be removed or rectified? For example, I'll illustrate with an example. Take the iron pillar on the Qutb complex. It still has a damage on it, which was suffered at the time when Nadir Shah invaded it, and he fired a cannon shot at it. Now that damage, how do you decide whether that has to be rectified or corrected or repaired, or whether it is history?
It's a question we deal with every day, and if I wasn't running so much out of time, I would have shown you a few more slides of our project in Hyderabad. And at Humayun's tomb, there hasn't been that problem. There haven't been past interventions, except the Curzonian addition of the sandstone channels, which we. So, as conservationists, what we do is we look at any past intervention, and we try to understand whether it is causing any damage to the building, or is it disfiguring the original historic character of the building, in which case we look at the possibility of removing it. There is also the question of age. So if some intervention like Nadir Shah's intervention, it's a historic act in itself, and often graffiti is also preserved because it's just so historic. However, at Humayun's tomb we have no such problem. On the other hand, at the Qutb Shahi tombs, we now realize that what you see at the Qutb Shahi tombs is not 16th century, but all 19th century work of Salar Jung. So what Salar Jung, the famous Salar Jung, was doing was adding his own motifs on the buildings. And in some cases, the original motifs have survived below. So there we are into this real game of creating templates, peer review, saying, what do we do? And what we've agreed to do is we worked out a very detailed list of, in this situation, this can be done, and in this situation, it's that template has been developed over months, and it is changing every week depending on what we find, because these are important decisions. Because over there, the building character has changed, and the buildings have suffered as a result of it. So essentially, we have absolutely no qualms in replacing cement. A lot of people, our critics, have said cement is a historic layer, leave it. but it's not a historic layer because it is causing deterioration. I've been roughed up, physically roughed up by somebody I won't name because he's still in service, but saying that the cement was added by our predecessors, it's a historic layer, and don't remove it. But essentially, if a past intervention is causing deterioration, it has to go.
I'll add to what Ratish said. You've asked a very fascinating question, because this is one aspect that we had to deal with when we were looking at the conservation of Red Fort. Now, what has happened is that, yes, Ratish is very fortunate that you don't have those multiple layers of history at Humayun's tomb, but when you look at Red Fort, you have distinctly 4 or 5 layers of history, starting from pre-Mughal to late Mughal, British and contemporary, and even the army intervention for that matter. Now, of course, there are a series of value judgments. You look at it from the archaeology, architecture, cultural, historical. There are various parameters that you would look into. And as Ratish mentioned, that then we tend to kind of go into, if there are past interventions which are quite sort of contemporary or later, that is something, if we realize it doesn't kind of contribute to the value of the monument or the complex, is something that then we decide to kind of take off. Now, for example, in case of Red Fort, whilst it has been decided to keep the British layer, so all the barracks and all are there, but the later layer, which was created by the army, is now systematically being removed. And the conservation plan that has been prepared actually again looks at these interventions in a way that if you have a Mughal layer, it has to be preserved as it is. If you have the colonial or the British layer, that is something which can be subject to reuse, or what we call as the sympathetic reuse. So any function which is complementary to the nature of the monument is something that we can allow that to happen. And of course, all the interventions which were done in the 60s and 70s is something that can be removed. Whilst there is no magical formula for that, but we safely kind of take a benchmark of about 100 years, that if there is any intervention after 100 years and that doesn't contribute to the nature of the monument, is something that we may consider undoing it, but only after a very thorough investigation and a process of decision taking. So I thought I'll add to what Ratish has said. Any more, please? Yes.
In geology, there's a phenomenon. In geology, there's a phenomenon known as eustacy.
Mic's not working, but
okay, without the mic.
yeah.
No, it won't record.
No, it won't record. I think we would have to.
In geology, there's a phenomenon known as eustacy, which is when you remove overburden pressure, there's an elastic rebound. Okay, and this is a very common phenomenon. Now that you've removed 1,000 tons of concrete, do you expect, or has this been factored in, that there could be a little upward movement of the monument? Because that might lead to another round of deformation.
Well, I removed 1 million kilos, so I don't know whether that's 1,000 tons.
Yes.
Is it? Oh, okay, that's good to know. Having said that, we removed 40 centimeters thick concrete. The roof is actually 3 meters thick. So, the original roof is that thick. We had a layer of 40 centimeters over it. So, it's nothing compared to the weight that is existing. As I said, the 1 million kilos sounds a lot, but these buildings were meant to take a lot of abuse. The reason it was important to remove it was not just the weight, but because the architectural elements had got buried in it. So, the sandstone, for example, started deteriorating. The rainwater spouts had got buried in it. So the water was collecting and seeping through, and so that is why it needed to be removed. But not only because of the weight. I'm sure 1,000, 1 million kilos, 1,000 tons was too much weight, and it would have helped. But we did a lot of thinking about it, because it had never been done before, and the Archaeological Survey of India was not very comfortable with the thought of doing this. And even at the Lodi Gardens, Intact noticed that there was this concrete which needed to be removed. It's a 20th century layer, but it is 1/7 of it is only a 15% increase in the total weight of the roof. Yeah.
So you mentioned that because of a design flaw, excess rainwater flows onto the facade and causes deterioration. Could it be that rainfall was different in those times and it's not a design flaw at all?
You have to study the last 500 years of rainfall patterns. Yeah, I have no answer to that.
Sir, I have a last question.
There is one more. and then
I think we will.
How would Humayun's tomb look like if you would not have intervened, because it was really neglected? And second, could you throw some light on your plans for Khan Khanna's tomb, if there are any?
He has to call me back for another lecture. Quite quickly, again, the thing is with conservation, most people look at a building and say, okay, it looks different, it looks good. So a lot of the appreciation we get, we say, oh, it's looking spectacular. But as a conservation architect, my biggest success would be if you can't tell what I've done. I mean, the minimal intervention is still the best way forward for conservation. The problem is, we inherited a building that had suffered 100 years of inappropriate or 150 years of inappropriate interventions. Because there was no money after the Mughal Empire declined and the knowledge had gone and so on. I mean, fortunately the building was protected. There were all sorts of things, refugee camps, angry Hindus living inside a Muslim monument, all sorts of vandalism had happened. So it looks very different because we've got the craftsmen back to do exactly what their forefathers did 450 years ago. But the bigger objective is that it survives for another 450 years in the condition. Yes, it will age. Yes, there will be problems. Yes, the problems will happen mainly on the plaster layer, which is meant to be sacrificial. And yes, it will need maintenance. But we removed cement from the base, so we had to lift 4,000 square meters of stone, and a lot of the money was spent on craftsmen wages. So I didn't go into every little bit of Humayun's tomb because we were talking about science. And Khane Khana is another story, but essentially, again, it's the same principles, it's the same logic, high level of documentation, multidisciplinary team, craft-based approach, high degree of supervision. Interglobe Foundation is giving us a grant, which is Indigo Airlines, for that work, so money is secure. We've done a conservation plan. The ASI has approved the conservation plan. Some work has started, but there are cracks the size about 2 feet wide cracks in the crypt, right under the dome. So our first thing, a lot of work which we will do will never be seen by the public, but it's just securing the building.
Is there a time perspective?
3 years.
Sir, I was in Uzbekistan last year. I am really quite surprised that you have anything to learn from them. Their restoration is a piece of imagination. And what is now on the buildings there is something which is Uzbekistan, Samarkand #2 rather than the original. But my question really on Humayun's tomb is that under that great platform there is a huge, I don't know what's inside that, probably some graves or whatever it is. But did you have to work under that as well? Did you have to do anything under the platform?
Two questions, one comment and one question. That surprised that we have anything to learn from Uzbekistan, because what Uzbekistan is doing in the name of conservation today is indeed questionable. But remember, we were not talking about conservation philosophy with the Uzbeks. We had craftsmen who were 85 years old and spent about 30% of their time while here in hospitals. But we were trying to get the craft skills back in India. We were trying to revive the craft skills.
And who took the craftsmen from here?
Tibur
took the craftsmen from here.
Yeah, history repeats itself. So the second question is we did not do any digging under the thing, but what you're talking about under the platform are 2 bay deep vaults which have 160 Mughal family buried there. Humayun's tomb was built as a family tomb. and 7 Mughal emperors are buried here. So there are a lot of crypts. So we didn't have to dig, but it's all accessible, and that's where most of the 200,000 square feet of cement was removed and 200,000 square feet of lime put back. On that happy note, I'm going to run away.
You drink water first. If there are no further pressing... so yours is the last one, then, Madam.
Just small question is that the Jamuna, which is so highly polluted, and it was running
Next to...
two at one time, and of course...
It wasn't polluted then.
No, but now. But how far is the Jamuna? Will it have any effect on
No, not at all.
the Red Fort and the underground?
No, not at all. It's too far now. No, it's too far. It's too far. It's very far now. It is very far now.
So the effect will not be there.
No, not at all. And well, I think I would have to conclude it now. It's almost 8 o'clock. Two things I was hoping. Well, Ratish, first of all, thank you very, very much indeed that it was such a fascinating presentation. And I'm sure all of us are quite enriched by the information that you have provided to us. Two things you haven't yet mentioned. While
ASI always has the last word.
Yeah, we have the last laugh. No, you very rightly mentioned that there was no conjecture that was allowed in the decision making. But what was also done while it was restoring the tiles back on those cupolas, whether it was those arches where the lime plastering and those decorations were done, that in the process of when he was removing those additional layers of cement layers from it, that when the original remains of those decorations and the lime, those tiles without the glaze, when we realized or discovered that, we took a conscious decision of preserving them. So if you would look at those cupolas carefully, it was only the missing portions or the portions where the cement mortar was applied that the tiles were put back, but the original tiles, even though that they are without the glaze, are still there. Of course, they are consolidated and preserved, but they are still there. And same is the case of those arches with the lime mortar. Wherever the original remains of the lime mortar or those decorations were found, they were preserved in situ. So that's why it was only in the remaining portions that the new work was done. And the case of lime is that it graces with the age. It sort of acquires a certain patina, a certain sheen. So it sort of merges with what the original the lime plaster would look like. So 2 or 3 years down the line, of course, with enough of oxidation, that the whole appearance would achieve its natural grace. So I think I would end with this comment, and I would like to thank once again Ratish for this wonderful talk.
वो सब सवाल नहीं आंसर